We are still solving equations. So we're still doing SADMAP, but this time we're going to look what happens if we have variables on both sides. Right now we've only been, or in the past, we've only been doing variables on the same side, and so we can get it by itself easily, right? But what happens if they're on both sides?
You gotta get the variable on one side.
You're exactly right. You're exactly right. So maybe I have something like 2 plus 5k is 3k minus 6. So what in the world am I going to do to get k by itself?
Subtract 5k.
So what I want to do, guys, there's lots of chitter chatter. I need to get the variables together on the same side. Then I can go through and solve just like I've been doing, okay? So if you look at this one, my question is, and David said move the 5k. My question is, how do you know which one to move? If I look at this equation, how do you know which one's the best one to move?
The smaller.
The smaller. Why the smaller?
Easier.
You're exactly right, George. Good job. You're not wrong if you move the bigger one, okay? But it's easier. Try to move the smallest. Because what's going to happen is that's going to keep me positive, and it's going to make my life a lot easier as I go. So as I look at this on both sides, which one is easier? 3, right. And so I'm going to move this over here.
But you're not actually subtracting it.
I am subtracting it.
Wait, I thought you weren't. I thought you just...
That's exactly right, CJ. All right, so look. Who didn't teach it right? Oh, shh, don't talk bad about it. All right, so we have to move it. We have to do the opposite, okay? Because it's got to cancel out here. The only way to cancel out is to subtract it, and because if we subtract it on one side, we have to subtract it on the other. These two are now like terms, which means I just combine the coefficients. So 5 minus 3 is 2. So it's 2 plus 2k equals negative 6. Don't forget that sign that's hooked with that 6 there, okay? So now, what am I going to do to get k by itself? Subtract 2. Contain yourself, David. All right, so 2k equals negative 8. And now, y'all, everybody's hollering the answer because at this point it's easy. K equals negative 4.
Negative 4.
Okay? Anybody confused on those if we've got them on both sides that way? CJ? Let's do it. I was just fixing to say, why don't we do a fraction one? Good suggestion, CJ. Y'all complain, but when you get it on your homework.
You ever got a negative on this?
All right. Shh. Let's do this one.
Have you ever given a negative on a test? I've gotten a negative on a test.
All right. That's not possible, David. Let's focus. Let's focus. All right. When I look at this, this is just like that one we worked from homework a minute ago, okay? If the x is in top of the fraction this way, I can rewrite it how? I can put it to the side. But there's nothing else with the x up there. What does it become? Good job, y'all. See, I tried to trick you. All right, 1/2 x plus 1. All right. Guys, CJ. All right, I've got variables on both sides. Which one should I move? The 1/4. Why the 1/4? It's smaller. A 1/4 is smaller than a half, right?
Facts.
If you have a 1/4 of a pizza, you have less than somebody who has a half of a pizza, right? Okay. All right, so I'm going to move the 1/4 But
Uh-oh.
the denominators are not the same. David, I see your phone. Just because you have something in front of it doesn't mean I can't
Very important question.
put it away. Thank you. Okay. 1/2 minus 1/4. How do I go through and make sure that the denominators are the same? What can I make them? What do I need to make them? 4, right? So I need to look at that very first fraction and multiply the top and the bottom by what? 2. Okay, so I get 2 over 4 minus 1 over 4, which is what? Woo! Go look on my desk. It's 1 over 4. We just do the tops, we leave the bottom alone, right? All right, so on the left, guys, keep your attention this way. On the left, I have 1/4 x plus 1. What does it equal? -6. Can you solve this now?
No.
What? I hope you can.
Oh, I thought you.
Subtract 1.
Subtract 1.
Negative.
All right, I got 1/4 x equals -7. How do I get rid of that 1/4? Flip. 4 over 1 is the same thing as just the whole number 4, right? What does x equal? Close. There you go. All right, let's kick it up an even bigger notch. Let's say not only do you have variables on both sides, George, but you have them written multiple times. So let's say we have variables on both sides. With other, I'm gonna say with other stuff. Okay, so maybe there's some parentheses. Maybe it's written multiple times, but there's other stuff there. It's not just a variable, a number, a variable, a number. There's some, so maybe it looks something like this. 6 times 5x minus 3 equals 1/3 times 24x plus 12. Okay? I can't just start moving variables all willy-nilly right now. Why? There's stuff hooked with it, right? You're right whenever what you're saying. You just didn't say it quite right, but I know what you meant. You've got to clean it up first, all right? So here's what I want you to do. I want you to make a note. When it looks like this, you need to simplify each side first. Okay? That could mean to distribute. It could mean to combine like terms. Whatever it is, look at each side and make sure it is completely simplified before you even start moving variables around. Okay? Yes, it's on both sides. Yes, I know I have to do something about that, but I really need to make sure that it's simplified before I start moving them around. Does that make sense? Yes, Ms. McKee. Thank you, guys. Thank you, even in my voice. Okay, look at the left side here. What should I do? You should distribute. Very good, Nigel. Thank you. What do you get? Y'all leave him alone. What do you get here? 6 times 5x is 30x. What do you get next? Minus, close, but there's no x here, so it's just minus 18, right? All right, let's look at the second side. David, turn around. 1/3 times 24x is 8x, right? All right, stop and think about that a minute. 1/3 of 24. So if you divide 24 by 3, that 8x came here. Look, come off to the side. That's 24 over 3, which is 8. Right? Because 8 times 3 is 24. All right, don't blurt this one out. Let's see if you can don't blurt it out when you get it, but just look at it. And what is 1/3 times 12? David, I am going to take it if I see it again.
Ask me for ibuprofen.
Well, tell them that's not allowed at school, so no, you don't have any. No. All right, 1/3 times 12. 4. Now you have an equation with a variable on both sides, so you're ready to simplify. What should I do? Why are you moving the 8x and not the 30x, CJ? Stop. Because it's smaller. Good job.
Is that considered drug dealing?
Minus 8x on both sides. Stay with me. Pay attention. 30x minus 8x is what? 22x. Minus 18. What's left on the right side? Positive 4. Now we got a two-stepper. That's easy, right? What do you do first? Plus 18 on both sides. This is gone, right? I have 22x equals, and somebody said 22, you're exactly right. X is 1. Oh, he's not here today. I want you to try this one. There's a few. You try this one. I'm going to pause the video while you try it, and then we're going to come back together to look at 2 special cases. All right, quietly. Yep. All right. Okay, y'all ready? Now help her out, but be nice. All right, tell her, what did you, wait, if she needs help. What did you do first, Ariana?
That.
That is exactly right.
That. Mm-hmm.
All right, so on the left, it's okay. We can scroll down if we need to. Keep going. You're good.
7
Equals.
-6.
Oh.
That's okay.
And
There you go. Y'all, good job.
And then.
All right, she's got to get her ends together. See, you did know how to do it.
9N. 9N.
Oh my.
Subtract 7. Equals -6. Plus 7.
No.
Plus 7.
You plus the 6.
Plus 7.
Wait.
Plus
Be
7.
nice.
Oh yeah.
All right, hit the eraser right here.
Now you know what.
Under the pen. Guys.
What?
Give it just a minute. Sometimes it negative.
Okay. Where was I? -7 equals -6.
Plus 7.
Yeah, you
There
are.
you go.
Plus 7.
Oh, that's where I messed up.
Scroll down here, Ariana. Scroll down on the side instead of. All right, guys. That is enough. Be respectful. All right, so now to get n by itself, what are you going to do? Divide by 9. That's exactly right.
So it'll be 9.
No, here, when you're on this step, divide both sides by 9.
Marianne, go under the 9.
There you go. So what's
Wait.
the answer?
Right there, put a 9 right there.
Yep, put a 9 right here. And what's the answer?
9?
1 over 9.
Oh.
Over 9. There you go.
Can I do one?
All right. Sometimes when we are working problems, some special things happen, okay? For example, I'm going to call this special cases. Let's say I start working this problem out. 5x plus 5. Yeah, 3 times 5x minus 4 minus 10x. Okay?
Oh.
This is an involved one, but that's okay. We can still do it.
So I have a question.
Hold on, because this is a special one.
No,
I
it
think
ain't,
I know how to do
it ain't nothing
it. Don't you
special.
subtract. Negative.
Just numbers.
Before I can subtract anything, I've got to distribute, okay? So that's not going to change. I'm going to distribute that. So 5x plus 5 equals 15x minus 12.
Subtraction.
Now remember I said simplify each side before you do anything else. Are both sides simplified? No.
Plus 10.
Oh, you got, it's a like term.
Combine like terms. You're exactly right. Shh. This is still not the special scenario I'm wanting you to see, but we're getting there, okay? So when I combine like terms here, what is 15x and negative 10x? Oh my. 15x and negative 10x
Are numbers.
is 5x. 15 minus 10? So now when you go to get your variables together, and you go, which one should I move? I should move the smaller one. But wait,
They're both the
they're
same.
both the same.
Do the
So
right
you gonna
one.
cross the both of them out?
So-
Go left to right.
If I do this,
Right.
Patrick said he's subtracting the right one, you said you're subtracting the left one, but at the end of the day, they both look like this. Because they're both 5x.
So you
Yeah.
cross both of them out?
So look what happens. You're exactly right. You're exactly right. There's no answer, okay? Does 5 ever equal negative 12? In any world, is 5 and negative 12 the same thing?
I mean, I'm sure.
No solutions.
That's exactly right.
Somewhere.
This is special case number 1. When you solve it and the variables go away and you get something that's not true, it is no solution. That means there is nothing you could go back and plug in an X and make that equation work. It will never, never, never work. There is nothing that works here, so we say it has no solution. Does that make sense to you? Yeah, that means they don't equal each other, so it means no solution. So you just write no. I just did the line through here means that 5 does not equal negative 12. They're not the same number, so that means no solution, okay? Now let me show you scenario number 2, and I know I've been talking a long time. I promise this is the last one and I'm done.
One and done.
I have been fighting with y'all this whole time to pay attention, I feel like.
Yeah, pretty
It's
much.
okay.
Scenario number 2. I want you to go ahead and simplify both sides of this and see what you get.
Can I do it?
Hold on.
You got what you said.
Don't look up, don't look up, don't look up. Do it on your paper.
Hold on,
I'm
wait till
still
we write it down.
Oh yeah, I'm still writing it down, man.
She gonna do
I said, ma'am. Using my polite manners. So I have those different.
Man, shut your mouth. That's a nice way to do it. Isn't there no solution to this?
No.
This one's a little bit different. Did everybody get 6b minus 10 equals 6b minus 10?
Yeah.
So let's move the variable. Okay, let me slow down.
I'm being B's and these sixes.
All right, when I get to this point, I got negative 10, you're exactly right, equals negative 10. That's true, right?
Yeah, so.
That's not a scenario like the last one. The last one wasn't true, but this one is true.
All the numbers.
What that means is there are infinitely many
Numbers.
solutions. Okay, that means what? No, you need to write infinitely many solutions, or you can write IMS. Either one's fine. It's different than infinity. All right, here's what this means. Anything you plug in for B is going to work. Okay, so that's where it can get a little bit choppy. If you solved it and you got 2 and you went back and plugged it in, 2 is going to work. If you solved it and you got 3 and you went back and plugged it in, 3 is going to work. So you have to know that whenever you get to this point, the answer is not -10. Don't say -10. If you check it and plug in -10, guess what? It's going to work because everything works. So you have to know that whenever you get 2 things equal to each other, that means infinitely many solutions. Okay? All right, those are your 2 special scenarios. They will be intermingled into all the other problems that you on the video, so you know. Let's say that I had, this was 2x plus 1, x minus 5, and if I told you that the perimeter of this triangle was 25, how would you solve that for x? What does perimeter mean? This side plus this side plus that side has to equal 25, and then you would solve it from there. All right.